Hi everyone, Darren from DrayTek Australia and New Zealand. In this webinar, I'll provide an overview of the high availability feature in DrayTek routers, which ensures uninterrupted network access in the event of a hardware failure. It's used to provide maximum uptime for critical installations. Here's an outline of the topics I'll cover today. I'll start by explaining what is meant by the term high availability, which is often abbreviated to HA. Then I'll go through which routers support high availability, followed by the two different availability modes. I'll include some configuration examples and demonstrations to show you how it works along the way, and I'll finish up by going through the latest feature added to DrayTek routers, which is a new variation of high availability using Virtual Router Redundancy Protocol. If you have any questions during the video, please comment in the chat box on the right side of the screen and stick around at the end for a 5-minute Q&A session. Don't forget you can pause the video or skip back anytime if you'd like a longer look at anything or if you missed something and want to hear it again. You can also give us a call or shoot us an email if you have any questions. Let's start by looking at what high availability is. High availability, also called hardware redundancy, refers to the capability of automatically switching hardware, such as to a standby router, when a primary router fails, whether due to a loss of power or something terminal. That ensures network downtime is minimized and mission-critical applications remain unaffected. For many businesses, even an hour offline can grind everything to a halt and cost a small fortune, let alone a day or two trying to source a replacement. So why is high availability important? Several reasons. The first is minimized downtime. Network services remain operational during hardware failures or other disruptions, which is vital for businesses that depend on continuous access to applications and data. The second reason is to provide business continuity. Even brief periods of downtime can result in substantial financial losses and reputational damage. The third reason is improved reliability. Organisations that implement HA solutions typically see an increase in network reliability. This builds trust with users and customers as they're more likely to experience consistent performance. Another reason is disaster recovery. High availability can be a fundamental aspect of disaster recovery plans, enabling quick recovery from failures and significantly reducing the impact on business operations. The last reason I mentioned is load balancing. Depending on the configuration of the hardware, it's possible to provide load sharing of internet connections. I'll talk more about this later. So where would you use high availability? It can be used for any mission-critical network installation that requires minimal downtime and/or for anyone who considers the price of a second router a small price to pay for redundancy. We've all become increasingly reliant on the internet these days, and being offline for any amount of time can become very expensive very quickly. A few examples I have listed here are company headquarters and hospitals, utility companies, data centers, as well as many other scenarios where network uptime cannot be interrupted. Not all DrayTek support high availability mode, so let's first take a look at the ones that do. Most dual and multi-WAN DrayOS 4 routers support high availability, such as the VIGA 3910, VIGA 3912, VIGA 2962, 2865 and the 2927. Linux OS routers like the VIGA 3900 and the 2960 also support high availability. For DrayOS 5 routers like the VIGA 2928 series, it's yet to be announced at the time of this video. One point to note is that with older router models and firmware, you had to have identical router models with identical firmware and country codes to set up high availability. For example, you had to have two VIGA 2925N or two 2925N+, but you couldn't do it using one of each, that is a 2925N and a 2925N+ as a pair. However, with later model routers and firmware versions, high availability will work between routers of the same series, such as a VIGA 2927 and a VIGA 2927AC. They no longer have to be identical. The only requirement is that both routers must have the same firmware and country code. To summarise, if you have a current model DrayOS 4 router running the latest firmware, you can use different model routers within the same series as long as they have identical firmware versions and country code settings. With older routers running older firmware, the router models have to be identical. Let's now look at high availability modes. There are two modes available. These are hot standby and active standby. In hot standby mode, both the primary and secondary routers share the same WAN source. To do that, you either need a modem with several Ethernet ports, such as the VIGA 167, or a hub or switch in between the modem and the two routers. For online status, only the primary router is online. When the primary router goes down, the secondary router comes up and uses the same WAN connection to connect to the internet. Also, the secondary router is synchronized to the primary router. Change something on the primary router and it automatically syncs to the secondary router. In this example, two routers are running in hot standby mode and connected to a common WAN source. LAN 4 is directly connected to router A, while LANs 2 and 3 are connected to the switch and configured to be in the high availability group, currently also serviced by the primary router, router A. So now let's look at what happens when the primary router goes down. When the primary router goes down, router B becomes the primary router, so all traffic from the LAN subnets in the high availability group are forwarded to router B. However, since LAN 4 is not part of the high availability group and is directly connected to router A, it will also go offline when router A goes down. You might set it up this way if LAN 4 is a guest network which isn't critical for the business's operation, so if that goes offline, they all just have to wait for the issue to be fixed. The other mode is active standby mode. Here, the primary and secondary routers have their own dedicated WAN connections. Both routers are active and can run independently to share the traffic load, but if one router fails, traffic for this router is redirected to the secondary router. In this mode, the router configuration is not synchronized between the routers. One drawback is that you will need two internet connections, but an upside to that is that you can load balance the traffic between the two WAN sources. Let's take a look at how that works. In the example shown in this diagram, two routers are running in active standby mode, each connected to a different service provider. We have LAN 4 being serviced by router A and LAN 5 is serviced by router B. Now, LAN 2 and 3 are configured to be in the same high availability group, which is serviced by the primary router, router A. Now let's look at what happens when the primary router goes down. So here we have the primary router, which is router A, going down. Now router B becomes the primary router, so all traffic from the LAN subnets in the high availability group is forwarded to router B. However, since LAN 4 is not part of the high availability group and is directly connected to router A, so it'll also go offline when router A goes down. LAN 5 is not affected since it's connected to router B, which is still online. So in this case, having LANs 4 and 5 directly connected to the routers makes more sense in terms of bandwidth management. These again might be guest networks or non-critical networks, so if either router goes down, they lose internet and can't share bandwidth while there's less available. You can have more than two routers at play. To make that work, all routers participating in high availability need to belong to a high availability group and share the same group ID. The group will need to have one primary router and at least one secondary router, but you can have up to 10 routers in the group. Keeping in mind that each router in active standby mode will need its own internet connection, so if you have 10 routers in your high availability group, you'll need 10 internet connections. In hot standby, all the routers share the same WAN source. Let's look at how high availability works for hot standby and active standby modes. There are a few items to be aware of when using high availability. The first is that Common Address Redundancy Protocol, CARP, is used for communication between the routers. Next is that a common virtual IP address is shared between the routers in a high availability group. LAN clients use this virtual IP address as the default gateway. If there's more than one subnet, each VLAN will have its own virtual IP address. When a failover occurs from the primary to the secondary router, the MAC address mapped to the virtual IP address is also updated to match the active router. I'll show you that in a little more detail shortly. As mentioned, routers need to be set up within a high availability group. This will consist of at least one primary router and one or more secondary routers. Each router within the group will need a different LAN IP address, but they will all share a common virtual IP address. In addition, routers within the group must have the same group ID. In the example shown here, we've set the group ID to be 1. So how is the master router determined in a high availability group? The way to do that is to use the priority ID setting. The router with the highest priority ID number will have the highest priority and will become the primary or master router. Where all routers have the same priority ID, then the router with the lowest management LAN IP address will become the primary router. The authentication key is used to encrypt the DRP traffic. DRP is an abbreviation for DrayTek Address Redundancy Protocol. This is done to guard against malicious attacks. As mentioned earlier, a virtual IP address is shared between the routers in the group. It's used to broadcast the MAC address of the secondary router when the primary router fails. In the example shown here, we have the IP address 192.168.2.1 as the virtual IP address gateway of subnet 192.168.2.0, which is LAN 2. And 192.168.2.2 is the primary router, and 192.168.2.3 is the secondary router. Notice the MAC address that is active in all LAN subnets is C6-4B-D8, which belongs to the primary router. Let's see what happens if the primary router goes down. When the primary router goes offline and the secondary router takes over, all traffic is routed to the secondary router. The virtual IP address remains the same, but its MAC address is updated to match the MAC address of the secondary router, which in this case is BE9260. When using hot standby mode, you can enable config sync to synchronize the primary router configuration to the other routers in the high availability group. In this example, we have the config sync set to 15 minutes, so if we change any of the settings on the primary router, every 15 minutes those settings are going to synchronize to the other routers in the high availability group. Another option in the high availability settings is the update DDNS function. This allows the same dynamic DNS account to be shared between all members of the high availability group. This means that when the secondary router becomes the primary, the DDNS profile will also be updated. This allows the network to still be accessible from the internet through the same DDNS domain. Another feature of DrayTek's high availability hot standby mode is that a single web content filter WCF license can be shared between all the members of the high availability group. At any one time, only the primary router can use the license, but if the primary fails and the secondary router takes over, it'll automatically register to MyVigor and continue to provide web content filtering. But that only works in hot standby mode, not active standby mode. Now let's take a look at the steps to set up high availability. The steps to configure high availability are as follows. First, note that the primary and secondary routers will have almost identical configurations except for the LAN IP addresses of the routers and the high availability settings, which must be set up differently. In order to establish high availability, we must initially enable it on every router. After that, we should assign a higher priority ID to the primary router. For all routers, it's important to apply the same redundancy method, such as hot standby or active standby, and use a group ID and authentication key. It's important to ensure that the management interface is set to the same subnet for both the primary and secondary routers. To proceed, establish a virtual IP address for each router. You can find all the necessary information for hot standby mode in the knowledge base article 5404 at the bottom here, but we'll step through the settings now. To set up high availability in hot standby mode, follow these steps. To access the high availability feature, navigate to the Applications menu and select High Availability. Then navigate to the General Setup tab. A. Provide a group ID number that must be the same for all members of the high availability group. Input the priority ID. B. As we previously discussed, the router with the highest number will be given priority and selected as the primary router. Be aware that if this setting is left at the default, or if all routers have the same priority ID, then the primary router will be the one with the lowest LAN IP address. Next at C is the authentication key, which is a text string and must be identical for all members in the group. D. Choose the protocol that you want to use, either IPv4 or IPv6. E, select the management interface. F, to ensure a smooth transition to the secondary routers in case the primary router fails and you're using a dynamic DNS settings, you can update your DDNS selection here. G, enabling syslog, assist with troubleshooting by viewing the high availability logs. H, select which LAN subnet or subnets will be used. And finally, I, for each subnet, enter the corresponding virtual IP address. These all need to be unique for each subnet. Remember that the virtual IP address must not match any other member LAN IP address. The next step is to enable configuration sync. If any configuration changes are made on the primary router, all secondary routers will be updated accordingly. If needed, the sync intervals can be adjusted to occur daily or hourly. To configure the secondary router, utilize comparable settings but assign it a priority ID number that is lower. To set up the routers, make sure each one has a unique LAN IP address that is not the same as the high availability virtual IP address. In this example, we have 192.168.1.2 as the LAN IP address and 192.168.1.1 as the virtual IP address. The virtual IP address will serve as the gateway IP address for all LAN clients. Keep in mind that if all routers in the group have the same priority ID as I've mentioned already, the router with the lowest LAN IP address will become the primary router. Here are the settings for the secondary router. The LAN IP address will be different, 192.168.1.3, but the virtual IP address remains the same, 192.168.1.1. In the case where a router has multiple IP subnets, it's necessary to assign a virtual IP address to each subnet. Here's an example of what that will look like. The WAN settings on the primary and secondary routers will be identical because they share a common WAN source. To ensure that the WAN configuration is accurate, you can check the online status of the router. To establish communication between the routers, you have to choose a LAN port as the management interface. In this case, we've opted for port P5. After connecting all the routers and ensuring that they're operational, you can verify the high availability status by clicking on the status link. When the two routers first connect, you'll see that they synchronize the configuration from the primary router to the secondary router, which will display as progressing. This will change to equal when the routers are synchronized. Keep in mind that the cache time shows the duration between router synchronizations. To refresh the details of the remote router, click Renew, and to update the details of the local router, click Refresh. To view more status information, simply click on the Details tab, which is illustrated here. Now let's look at a new feature added to DrayTek routers in the latest firmware, which is high availability using Virtual Router Redundancy Protocol, abbreviated to VRRP. It's available in firmware versions 4.5 and above in the VIGA 2865 and 2927 routers, and firmware version 4.4.5 and above in the VIGA 3912, 3910 and 2962 routers. Using VRRP offers several benefits. One significant advantage is that you can utilize two different DrayTek routers, such as a VIGA 3912 as the master router and a VIGA 2865 as the backup router. Although router configurations vary, the backup router can still provide internet access to devices on the LAN using a shared virtual IP address. DrayTek routers are compatible with both VRRP versions 2 and 3, allowing them to work with routers from different brands to ensure network redundancy and continuous internet access in the event of a primary router failure. Each router will have its own internet connection and configuration, as shown in this diagram, but they will share a common virtual IP address on the LAN. Let's go over the steps required to set up high availability using VRRP. Detailed instructions are available in Knowledge Base Article 12194 shown here. The first step is to enable high availability and select the VRRP protocol. To do this on DrayTek routers, go to the Applications High Availability menu page. Enable it, and from the protocol drop-down list, select VRRP. To start the configuration, click on the first available profile. On the next page, tick Enable and enter the required details. Enter a VRID. This has to be the same for all routers in the VRRP group. Select the VRRP version 2 or 3. This also has to be the same for all routers in the VRRP group. Next, assign a priority value. The router with the highest value will become the master. The preempt setting determines whether the router with a higher priority will take back the master role after it recovers from a failure. For security, you can turn on authentication using an authentication key, which can be a text string. Next, enter the interval in seconds that the master router will send the VRRP advertisement to inform backup routers that it is still active. Now select the management interface. Finally, enter the virtual IP address. This will be the shared IP address used by all routers in a VRRP group. It acts as the default gateway IP address for hosts on the local network. Then click OK to save. Here are the completed profiles for the master and backup routers. We've set a priority of 200 for the master router and 100 for the backup router. Once everything is connected, you can check the high availability status under Diagnostics VRRP status in the 3912 router and under Diagnostics high availability status in the 2865. To test failover, ping the virtual IP address, then switch off the master router, and you should see maybe one lost ping while the backup router comes online. To summarise, we started by looking at what high availability is and which routers support it. Then we looked at the two high availability modes, which are hot standby and active standby. We also looked at how high availability works and how to configure it. Finally, we looked at the latest feature added to DrayTek routers, which is Virtual Router Redundancy Protocol, VRRP. Okay, that's it for me, but please stay tuned. Our technical team will be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification anytime we put up a new video, please select all from the subscribe drop-down menu as well. Thanks and bye for now.